Alright, so our next notes in algebra are going to be from lesson 3.3, and it's going to be on rate of change and slope of a line. These things are really closely related. Really, when we're talking about the rate of the change of something, we can measure it within a coordinate system by the slope of the line, if it's a linear equation. One of the things we want to define first is the rate of change and what it's really talking about. So maybe that's something that's not quite clear to you. So we'll go ahead and define it here, then talk about it a little bit. But a rate of change is a ratio, like one thing over another, that describes how much one quantity changes with respect to another. You can think of, like, so if I buy candy bars at the store, some stores, the more candy bars you buy, the cheaper they are. Or maybe you go they like to sell drinks or whatever, like those 20-ounce pops or whatever. They might say you buy 3, get them on sale, like that. So you can compare ratios or make a ratio out of different things, like the cost to how many I buy, and things like that. But the equation we're going to use for that is rate of change here down the bottom, and move that up a little bit. So rate of change right here, and the equation is really change in y over the change in x. So when you see y and x, you should kind of think algebra, right? Because we're talking about x's and y's and how they're related to each other. And we've been talking a little bit lately, the last couple lessons, about functions, f of x, and how that relates to an equation with something with an x in it. So we're really talking about algebra here. But the equation we have for rate of change is the change in y over the change in x. If we were going to look at an example problem, how to solve these rate of change, we might look at something like number of games. Say you go to Fred Meyer's and you want to buy some video games, and it says, they tell you how much they charge for how many games, and you might see, so x is the number of games you buy, and y would be what's the total cost, because that could be variable. But you decide how many games they buy, and then the thing that's determined later is what you pay, the cost. So we can see here, 2 games cost $78, 4 games cost $156, 6 games cost $239. And then we can use this equation, change in y over the change in x. So the change in y, we're going to go from one y to the next. Okay, and we're going to usually go with the larger amount. So it's really going to be y2 minus y1. So this would be our y2, our second y, and then this would be our y1. So we'd have 156 minus 78, because that's going to be the difference. So really we could say y2 minus y1 here as well. At the bottom we want to do the same thing, x2 minus x1. We do the same thing we did here, x1 and x2, then we'd have 4 minus 2. So at the top we have 156 minus 78, that's the change in the y. And at the bottom, 4 minus 2, that's the change in the x. Then we just simply do the math. We'd end up with 78 over 2. And then we want to simplify that. We'd end up with 39. And you can see I've already drawn a dollar sign here. So that tells us $39. And that's our answer, right? That's the rate of change that we see in this table right here. Okay? And you say, well, what does that mean? Right? So what does that really represent? Well, in the end, it represents how much per game. So how much per game? It's $39 per game. And then you might even check, we're not going to do that right now, but we could then compare the next one. So does the rate of change continue? Does it go up or down as we buy more and more games? We're not going to check that, but we could and see if it's the same. We just go down one and do the math again. So that's kind of what rate of change is talking about. You compare how the y is changing to how the x is changing. So we go to the next page. And you could ask yourself, is a change linear? Then our next concern is that. So is our change consistent? Because I was asking you, if you remember, I was saying here at the bottom, does it always stay that way? So when I go from buying 2 to 4 games, it's $39 per game. And then 4 to 6, is it staying the same? Is it going to be the same rate of change? Well, there's an easy way to check that. And by linear, it means the change is the same. And you can see that here. It means a constant rate of change, and it's the same change over and over. And you just need to check data points. Okay, so what we want to do is figure out two of these, and we can use our data points here and figure out the change. So we can make this y1, y2, and then x1, x2, and we could do the math, right? So if we did this one, y2 would be -8 minus 6, or -6, I'm sorry. So minus a -6 over 4 minus 1. We would then end up with, we'd want to change the sign and add. So we'd have -2 over 3. So -2/3 would be the change there. And then we could check somewhere else. We could check the next one and see if it's the same slope. We'll just go to the next one. So we've already checked these first two, so we'll just go down one. We'll make this x1, and the next one x2, this one y1, and this one y2, and we do it again. So we'd say -10 minus -8 over 7 minus 4. And we'd see we're going to change the sign here. It's going to be -2 over 3. Same slope. So that tells us it's a linear change here. If the rate of change is linear, it's consistent. It's not going to change. Okay? So we can count on it. So then if we did the other example here, let's see if this one here has a different change, or rate of change. So here we again, we'll start with these one over here. This is your y1, y2, x1, x2. So then we do 12 minus 10 over -1 minus -3. This would be 2 over, this would be change the sign and add. This would be -1. 2 over 2 would be 1. So then we want to check the next one, right? And we'll make this y2 then, this y1, this x1, this x2. Then we do the y again, 16 minus 12 over 1 minus a -1. Okay, and then we might see 16 minus 12 is 4, and then this is going to be 1 plus 1. It is 2, because we changed the sign and add. So now we have a rate of 2 instead of 1. So this is not this rate of change is not constant, it's changing. And we might even see a pattern. Here, let's see the next one. We have 1, 2. How about if we do the next one, see if it's 3. y2, y1, x2, x1. So we did 18 minus 16 over 3 minus 1. This is 2 over 2. This comes back to 1 again. So this is not a constant change. And we can see that just by calculating and using our data points in the equation for rate of change. Okay. So then if we keep going with this idea of rate of change, another term that's really synonymous with that is slope. So if we look at the definition of slope, it is, let me get this straight, it's the rate of change between the y-coordinates and the x-coordinates as you move from one point to another. The equation we use for that is m equals slope, or m is the same as saying slope. This is what I use to abbreviate it. It equals the rise over the run. Okay, the rise is up and down, it's y. The change in y over the change in x. And I've been kind of alluding to this because I've been using these y2 minus y1 and x2 minus x1. But this is really the equation. We would usually see m equals this last part, y2 minus y1 and x2 minus x1. So that would be our equation for slope. So if we then look at the next part, some qualifiers for slope. We want to remember there's some different possibilities for slope. That slope can be positive, and that means when we look at a line, that the line will go from left to right and will go up. And that will tell us, without even calculating the slope, it's a positive slope. But then if the line is doing the opposite, like this one here, and it's going down, we would then know that the slope is negative without calculating slope or anything. And then a third possibility, if we see this one right here, a slope of 0, that means it's not going down at all, it's going straight across. That's what we call a slope of 0. And that's where y can be anything. Y can be a specific one number. This might be a 10 on the coordinate plane, and it doesn't change. Y is always equal to one number. And you'll see that kind of expressed as something like this. F of x equals 12. Something like that. Or f of x equals 3. There's only one number over here. If you remember, f of x, the function of x, equals y. It's really saying y equals 3 or y equals 12. So then one last possibility is we have slope that's undefined. Okay, and that is a vertical up and down line. So that's where we have something is equal to an x. Okay? So that's those important qualifiers. So whenever time we have slope, we can have a positive slope going up from left to right. We can have negative slope going down from left to right. We can have slope of 0 going straight across on the horizon, and we can have undefined going up and down on the vertical. So then I just want to show you some examples of how to do this. And so if we have, say it gives you the two points, the two x's and the y's, the coordinates for 2 points on the line. So we have -2 for the x, 0 for the y, and then we have 1 for the x and 5 for the y. We just take them and plug them in, right? Because we have this equation, m equals y2 minus 1, x2 minus over x2 minus x1. We just plug in the 5. That's from there. 0 from there. This 1 is from there. This -2 is from there. We do the math, and here we get 5/3. And you can see it, no negative sign, so we know it's a positive. So if we graph this, we know the line would be going up from left to right. You could also get, not the points, but you could get like a table that gives us x's and y's. So you could have here, same thing, y2 minus y1 over x2 minus x1. We just plug in our numbers again. So we do, this would be our y2, right? And y1, this would be our x2 and x1. I'm not sure it matters either. If you do the other one, I think you get the same answer. But so you do that, so we plug in our numbers, right? And then we get -7/5, and that's a negative slope. Okay? And one more example of something you could be asked to do with using slope, a little bit more complicated, really test your algebra abilities. Okay? This says find the value of r so that a line through 1, 4, and -5r, so we need to find the value of one of those coordinates, but it has a slope of 1/3. Again, we're just going to use that equation that we had before. We just use this m equals y2 minus y1 over x2 minus x1. And really, we have these points, but we're missing one. So we're just going to leave that, make that r, plug in the rest of the numbers, and solve it, right? So let's look at that. So if we do that, we have the equation, right? So we see m would usually be where the 1/3 is, but it tells us what the slope is, so we can put that in for m. And then we put in r, we'll just make it, looks like they made it y2. So r minus 4, that's from this one. And then -5 is that one. And then -1 comes from that one. So, or -1 comes from that one. And then you do the math. So you have, this is your total equation here, right? So then you have to do some cross multiplication. So you have a 1 and -6 here. You have a 3 and an r4. So when you do that, you'll see you get this on one side and it equals the thing on the other. That's why we did ratios, so we can do some of this. We just do your distributive property. 3 times the r and 3 times the -4. We get 3r minus 12 equals -6. Then we just add 12 to both sides. And we get 3r equals 6. Divide by 3. We get r equals 2. That would then tell us this point right here that was -5r, we would then plug in the 2, because that's what y is equal to. That's kind of how you do this. I hope this makes sense to you. Let me know if you have any questions. We'll go over a few of these in class tomorrow. and examples of how to use it. Just make sure you add these notes to your notebook, and let me know if you have any questions.